Hello everybody, just a little tutorial about this question on enzymes here. Okay, so using keywords that you've learned through the course, explain how enzymes are affected by temperature. So I just drew that graph here that you should be thinking about in your mind. Okay, this is how enzymes are affected by temperature. I've got 3 parts to the graph pretty much, and I've got 3 marks in the question. What I do have to do is, rather than just describe what happens, is I have to explain. So key term, really, the really important bit is this command term, explain. So I have to give reasons, right? I'm not just going to say, oh, rate increases, then it's an optimum, and then it decreases. That won't be good enough. So first point, really, I have to start talking about kinetic energy. Okay, so kinetic energy at low temperatures, it's not very much, which means there is not a lot of kinetic energy. There's not a lot of movement in the particles. As we increase the temperature, up to here, say we're getting an increase in kinetic energy. Kinetic energy increases with increasing temperature. Okay, now on its own, really, I would say that's not enough, because that's not an explanation in itself. Okay. Kinetic energy increases with increasing temperature, which means the rate of collisions also increases because of this kinetic energy increase. All right. What's colliding with what? Okay, so substrate is colliding with the active site on the enzyme more often. Yes, and if it's colliding with that active site, then it's going to be able to form that substrate active site complex. All right, so that's kind of part A. Low, anything that tells me that low kinetic energy or low temperature gives low kinetic energy, which means there's fewer collisions as well, that would score you a mark too. Okay, so then we need to be concerned. Okay, so we've gone up from low to high kinetic energy, so we've got lots of collisions happening here, more so than at A or lower. But what's happening at C? So as we go over the optimum, we don't just say that reaction rate decreases. We say at high temperatures, denaturation occurs at high temperatures. And this involves a change in the shape of the active site. So that's the explanation. Denaturation is just more like a descriptive term, really. It doesn't really explain what's going on. So the change in the shape of the active site, okay, gives you that mark. I'm not just going to accept denaturation on its own. Okay, and I also discussed, okay, so low temperatures gives low kinetic energy, which gives low collisions. Yep, or low frequency of collisions. Okay, so 3 out of that lot, I'd say 1 and 2 are actually linked, so a bit like number 5. If you say kinetic energy increases with increasing temperature, therefore the rate of collisions increases, that would get you a mark. Substrate colliding with the active site more often, and then the denaturation, change in shape of the active site, gives you another mark. Okay, so keep this graph in your head when you're answering these questions, and that will help you get those 3 points